What's good, everybody? This is CreamSpinachYo, and I am bringing you episode 5 of Math, Science, and Modern Warfare 3. And today, we're gonna stick with the math, and we're gonna talk about a topic well, not really a topic, an idea in modern algebra. And if you are unfamiliar with that term, it is also called abstract algebra. Now, the realm of modern algebra is pretty cool. It deals a lot with why the basic properties that we take for granted work. And so today we're just going to explore one idea of that. And judged on the title of this video, it's going to be something very cool. So today we're going to talk about why there is a case where 2 plus 2 does not equal 4. And I know what you're thinking. You're thinking, oh my god, why on earth did all my teachers lie to me? My parents, oh my god, they lied to me too? Unbelievable. But no, they did not lie to you. 2 plus 2, we're going to be talking about a specialized number system in which 2 plus 2 does not equal 4. And now, this number system is called the integers, right? We should be familiar with the integers right now. You've been working with them ever since you were a kid. Even in kindergarten and elementary school, you were working with integers. Now, in case you are unfamiliar with the set of integers, the set of integers contain all the whole numbers that are negative and positive, as well as 0. So you can think about this as -3, -2, -1, 0, 1, 2, 3, and so on, in both directions. Now, the cool thing about the integers is that we can do a lot of neat stuff with it. For example, we can split the integers into subsets. So, if you are unfamiliar, I'm going to explain a subset right now. The integers is a set, right? It is a collection of elements. Now, a subset is when you take those original collections of elements, so in this case, the integers, and you form another set of elements from that mother set. That's what we like to call it, because everything comes from that set. So for example, let's look at Z sub 3. Now, Z sub 3, right, is a subset of the integers, and it contains all the elements 0, 1, and 2. Now, because we're looking at Z3, when we add or something to Z3, since those are the only 3 numbers in that set, if you were to go past 2 from the set you're seeing, then you would go back to 0, and then to 1, and then to 2, and then back to 0. So in this case, if you have, I don't know, let's say you have 5, right? You start from 0, and you count 5 times, 1, 2, 3, 4, 5, and look at that, 5 is defined by 2 in Z3. So this is how, and you can kind of see where this is going, why 2 plus 2 will not equal 4 in this case. And so, in case you're wondering, you can do this for any Z you want, for any subset of the integers you want. And here's a generalization of the subset of the integers right now. And you can see that Zn will contain 0, and then you can go comma, 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 n minus 2, comma, n minus 1. So for example, Z10 will contain all the integers 0 through 9. Z over 9,000 will contain all the integers 0 to 8,999, right? If we're taking it Z sub 9,000. So you can understand the generalization of this set. Now, let's actually take the example 2 by 2 plus 2, right? And let's assume that we're working in Z3. Now, I know what you're thinking. You're thinking, Matt, you just told me that the set of integers is contains negative numbers and positive integers. Why are we only looking at this set? Why are we only looking at the positive ones? And the reason why we are looking at the positive ones is because of an idea in abstract algebra which states that you can always find, if you have a group, which I will probably talk about in another episode. But we don't need to. The idea of the story is we don't need to worry about the negative numbers. Of course, we can talk about it, great, but in this case, we don't concern ourselves with the negative numbers. We only talk about the positive integers. So if you're working in a z sub whatever, just remember it's always positive. Now, back to the example, right? Let's take 2 plus 2 in the area of z3. Now, when you do this, right, we start at 2, right? Clearly, we start at 2, right? So we have the set z sub 3, and that equals the elements 0, 1, and 2. And now we start at 2, and we add 1, right? So we're halfway there. And since 0, 1, and 2 are the only elements in z3, we move to 0. And then we add another one, so we get the full 2 plus 2, and we end up with 1. And oh my god, 2 plus 2 equals 1. Now, if you don't want to write out z3 and all that crap, you can see right here that you can write 2 plus sub 3, 2 equals 1. Now, when you write that, it is automatically assumed that you are working in z3. Do not write 2 plus sub z 2. That just that won't make any sense. So don't do that. So you can see clearly that 2 plus 2 in z3 equals 1. Now, let's say you want to do this without writing all that fancy math. Sure, no problem. There is a way, there is kind of a system to get that answer, right? You take 2 plus 2 in regular math, right? And you get 4, duh, right? And since you're working in z3, you subtract 3 from the 4, and oh my god, you get 1. Isn't that cool? Now, although this doesn't really, the example I'm giving you right now, it does require a lot of theoretical know-how to get to this point. So I am jumping ahead. I am jumping the gun a lot. But take it at my word. I'm not leading you astray. If you really want to learn about it, you should definitely research group theory and the idea of homomorphisms and all this transitive properties, symmetric properties, reflexive properties, and equivalence relations within the world of modern algebra. And yeah, I know this is an 11-minute video, but that is it for episode 5 of Math, Science, and Modern Warfare 3. And now, instead of continuing with the math and science, I'm going to talk about something else completely different. Right now, I'm working on more math and science videos about the channel. I'm doing research for the next episode, and that should be up soon. I'm working hard on my road to Commander. I got a couple of topics in the pipeline right now, and it's going to be very cool. And I just want to be absolutely clear that when I make these videos, I make a couple videos a week, and that way I have, and if I post 1 or 2 videos per week, I have a good couple months of material already set to go. Right? I have a couple months of stuff that I can just, if I'm really busy, I can just post it and then done. So I keep fully done, edited, rendered videos for the channel on my computer, so I don't overexert myself, really. I make sure I don't get too overwhelmed with the idea of maintaining a channel. So I hope that's okay. Sure, I do have a ton of gameplay backed up. So if you do have a suggestion for a topic, either in the Road to Commander, or for a general commentary, or for the Math and Science series, just leave a comment in the comment section. And if it's a viable topic, I will see what I can do about it. I cannot guarantee that every topic I can do. That is, if I get 100 comments all different and they're all good topics, I'm not going to do all 100 topics. I'm going to pick the ones that are more kind of, I have to talk about like the accessibility of the topic and how well I can articulate it over the air with pictures and my voice. There's a lot of factors within this that makes a big difference. Now, the next video will probably focus on physics, because I know I've done several episodes of math in a row, and I think that's good for this video. Again, with the example I showed you, that 2 + 2 and Z3 = 1, you can make up your own problems like this for really any Z you want. I mean, provided that if you can take an integer, and if you double it, and if it's outside that Z sub number that you're working with, then it will work like I showed you here. So you can take 3 + 3 and Z5, and you'll get 1, and you can just keep generalizing that completely. So thanks for watching. I really appreciate it. I do have a Twitter. Feel free to follow me at CreamSpinachYo. And hopefully, I know I'm still working on the validity of the commentaries. I'm not that great. I do say and pause and a lot. But nevertheless, thank you for watching. I really do appreciate it. Feel free to subscribe to the channel and like the video, and I hope you have a great day.